Hello, everyone. Good morning. So we're going to be talking about HTTP3. We've been working on it for about 4 years. Pretty big release for us. We're also going to end with a very powerful demo, a self-driving car demo. We'll walk you through the steps. In only 10 minutes, so we'll go very fast. HTTP3, we announced it on June 18th. You saw it a few days ago. It's got a lot of good reception. It is very powerful. Across the board changes across all ecosystem. And we're also expanding the ecosystem. HTTP3, it's faster and smarter. Means I can deploy containerized TensorFlow in minutes. And with GPU pooling, I can reduce the insight by 50x, time to insight by 50x. That's pretty powerful. It's also bigger. So with HTTP3, I can cut down my TCO by half, and I can increase my scale by 4x. So if you can see here, today, if I use my cell phone or my internet, I use about 1.5 gigabytes of data per day. If you look at smart devices, we generate up to petabytes of data, especially a self-driving car. Over lifetime, I can generate up to exabytes of data per self-driving car. Huge, huge, powerful, right? So HTTP3 really goes behind that. So now we'll talk about a very interesting use case. So it is I asked John, can we spend 100K on a Tesla so that we can hack it Komaya style? He said, no. You can only get like 10K or maybe 8K. So we said, fine, you'll get a 1/10 miniature car. So that's what the car you're seeing here, right? So it has a NVIDIA GPU for inference. It has a 3D camera in there. It also has a LiDAR. And LiDAR is the most expensive part of the car. And it goes around, and what we do is, this is a fun project. You can see these pictures are from midnights and weekends. That's our 20% project, right? And we're debugging all the models here. So when we got the car about 4 weeks ago, the car was like a 5-year-old. You can see, right? It's driving around, have no clue what's doing. Then we decided to bring in HTTP3. So it's a 5-node HTTP3 cluster with GPU, 6 GPU cards, using HTTP3 technologies. So we start taking data. The data includes frames, all the pictures. It also has a steering angle. So we took the data, about 30,000 images, put it on HTTP3 cluster. Instead of having separate GPU cluster, I train it in the same cluster. And once the model is done, I deploy it back to the car. Right? Pretty powerful. And the car now can drive. So the magic that happens, go from a 5-year-old to a 16-year-old driving like a human, that happened in HTTP3. And we're going to walk you through how the magic happened. So with that, I'm going to pass it to Vinod. Sorry.
Thanks, Soumitra. Yeah, for the rest of this demo, I'm going to work closely with Wangda. I'm Vinod. I've been doing Hadoop for more than 10 years now, and Wangda is one of the key contributors in Yarn recently. All things scheduling. Internally, we have a joke that I'm the resource manager, but he's the scheduler. So together, we're going to show you some of the things that we've been doing. Last year, when I was on stage here, Hadoop 3.0 was still in alpha. And kudos to the Apache Hadoop community. We have made a 3.0 GA release in December last year. We followed that up with a 3.1 release earlier this year. Building on top of all of that great work in the Hadoop community, and all the related big data projects, we have something to show you today with HTTP 3.0. What you're going to see here now is right here, sorry, is a 3.0 cluster set up by Ambari 2.7. For those of you who are familiar, Ambari 2.7 has a new skin, and a bunch of usability improvements. What we have here is the latest and greatest of HDFS, Yarn MapReduce, but also HBase 2.0, Hive 3.0, Kafka 1.0, Spark latest, and so on, right? But for the rest of the demo, we're going to simply focus on storage and compute. Let's go to storage first. So in here, with Federation being GA, through the user interface, we can create multiple namespaces, and that's how you can scale the namespace. And if you want to scale it further, you can always go to the actions and click on add namespace, right? That's the operative view of the storage. In terms of how the user sees the files, you can go to the file browser interface. And this is the familiar root file system. The specific thing that Wangda is showing here is the car data. We haven't put all the data here because it's going to take a while to load. This is 15,000 images. taken over the course of 6-7 minutes. And as you can see, one of the core goals here is to minimize the storage cost. So all of these images are in a erasure-coded zone and read Solomon 3.2 encoding, right? So that's on the storage piece. Now let's go to compute and see what we can do with this data. This is again familiar Yarn, all the greatest and latest of Yarn. From the operator point of view, we have simplified a few things here. You can do a single-click enable Docker runtime with Yarn. Yarn can now do containerized and non-containerized apps on the same cluster. We can also do GPUs and do a single-click and enable GPU support. This way, you can bring all of your existing analytical, interactive workloads along with deep learning workloads, right? That's the operator's view. Now go to the user's view. Again, similar to Ambari, we have a new skin in Yarn, which shows all the important things. If you go to a single machine, we have a few machines here, 400 gigs RAM, 50 cores. And we also have GPUs, and we use NVIDIA Tesla. A couple of GPUs are here. And because we use the NVIDIA tools to integrate GPUs, we actually can show what the GPUs are doing here, what's the temperature, and so on, right? Last but not the least, because Yarn supports containers, apps, and service apps, we've made it sure that you can actually go to a single page and see all the services that are running. We have a few services that are running here, like HBase, TensorFlow, and so on. Now, Wangda is going to walk us through the rest of this interface and go through the data science experience.
Yeah, so thanks, Vinod. So as a data scientist, we can very easy to use the notebooks to develop our model. So by clicking the new service, we can very easy to deploy the TensorFlow Zeppelin notebook just in one single click. So let's go back to the already running notebook. And we can go to the quick link UI, goes to the Zeppelin notebook. And we can, inside this notebook, we're going to use this to develop our model from end to end. First, let's import some Python libraries, such as TensorFlow, Keras, Pandas, and NumPy. And let's look at the data. So this is a photo taken by the car's camera. And below that, it's each entry. We have one photo, one steering angle, and one speed. By clicking the night chart, we can see how the car is turning over time. So first, we can see the car is moving straight, turn left, moving straight again, turn left. By using this very powerful virtualization tool, we can understand our data in seconds. So this is the most important piece of the data scientist. So let's look at how we do the training here. By clicking this, we can start the training. And below that, we are using Keras, and which run in the GPU pooling supported by Yarn. And so for this, we can reduce the time by 50x. So, but this will still take a while, so let me cancel this. And once the model is generated, we can deploy this to the car. And this is the first model we deployed. As you can see, this doesn't run well, so we come back to fix this. So to debug the model, we can load the model back, and we can do some predict for some sample image. This is a sample image, and this is what the model can see. So, so we found the problem from this because the model somehow cropped the image by half, so this doesn't work well. So after several iterations, finally we fixed this model. And thanks for all the contributors to this project.
All right, Wangda, that's awesome. So you saw how the magic happens in HZP3, right? So all the data experience of the car happens in HZP3, and you convert a car from a 5-year-old to a 15-year-old, right? So that's the car here. I had a remote, right? I'll have a script. I can start a car, and without anything, the car is running. So basically, what it's doing is, in real time, using LiDAR data and also the camera data. And in real time, using the GPU inference, converting the car image to a steering angle. So now the steering angle, I can know how to turn left or right. I mean, yeah, it's simple, right? Let's do something fun, more fun. So Vinod, do you want to step and see if we can stop the car?
Absolutely.
So there you go, right? So using LiDAR and computer vision, you can stop the car, run the car, and drive like a human. So, and HDP3 is behind that to go from a 5-year-old to 16-year-old. With that, thank you so much. So we'll go to the last slide. So HDP3 is faster, smarter, hybrid, all this, right? So please go to our booth to know more about the car and HDP3. We also have early access bits that you can try it out. Thank you so much.
Yeah, thank you.